Before starting the experiment, make sure you are wearing your goggles and have proper lab attire on. And during the experiment, you want to ensure that all materials are being used carefully and that no materials are wasted.
Prior to diluting, we have to have all of our materials. This includes a volumetric flask, a beaker, and a graduated pipette, as well as our solute and solvent. In this case, we had our universal solvent, which is water. Before diluting, we had to add around 5 milliliters of stock solution to a graduated pipette. In the volumetric flask, we had about 5 grams of water. The transfer of the stock solution to the beaker allows us to prevent pulling directly from the stock solution container. This is to eliminate waste. If we had already measured out how much stock solution is in the beaker, then we can get the graduated pipette to accurately give us how much stock solution needed, without having to worry about cross-contamination, which is why we don't ever put the stock solution that has been taken out back into the stock container. So in order to measure the volume of our stock solution and put it inside of the volumetric flask, we had to use a graduated pipette in order to get the volume of the stock solution. We identified the volume by viewing the meniscus. We found the mass by measuring the weight in grams for the beaker, and afterward we measured it again after we had put some of the solution in, and when we took it back out, it was the weight in grams of what our solution was. And then in order to find the density, we did mass over volume, and that's how we found our density.
The stock solution is the 20% stock solution or sugar water that we used. It is prepared so you can make solutions of lesser concentration from it. We measure it by finding the mass using the balance. We measure both the mass of the empty flask and the mass of the flask with the solution and then find the difference. We find the volume of the sample by using the graduated pipette or graduated cylinder's marks and find the volume to 1 degree of uncertainty. Then we find the density of stock solution by dividing the mass by the volume. Dilution is when you create less concentrated solutions than the stock solution. The dilution is done through the use of blue water diluting the stock solution to 25 milliliters. The dilution equation is the concentration of the initial solution times the volume of the initial solution and equals the concentration of the final solution times the volume of the final solution. Stock solution relates to the dilution because the stock solution represents the initial half of the equation and the dilution represents the final half of the equation. Our intended outcome was to create a calibration curve for the sugar solution using the densities and concentrations that we found, as well as finding the standard deviation for the samples of solution.
By reading the meniscus, we can identify the stock solution and blue water's volume. When measuring the volume of the stock solution, make sure you read the meniscus to 1 degree of uncertainty. This just means recording your number to the 100th place of the number you see to get more accurate data. To further ensure accuracy, make sure you read the meniscus at eye level. The meniscus, created by adhesions, allows water molecules to stick to objects of different material. In addition, the water molecules stick to the side of the pipette because of water's high surface tension.
First, in Challenge 1, we found the density of water by measuring the mass and volume of 4 different samples while using a 10 milliliter graduated pipette and a 100 milliliter graduated cylinder. Then we found the standard deviation of the density samples. Next, in Challenge 2, we collected data to establish the relationship between the concentration of sugar in an aqueous solution and the solution's density. We prepared a series of sugar solutions and measured the masses and volumes to find the densities. To start, we were given 20% stock solution and a 25 milliliter volumetric flask. We used the dilution equation to discover the final concentration of the new solution. Lastly, in Challenge 3, we found the mass and volume for the density of unknown solution number 962. Then we plugged in the volumes and final concentrations from Challenge 2 into an Excel sheet to produce a calibration curve. Using the curve, we identified the calibration equation to find the concentration of unknown solution number 962.